Unit 2, Lesson 1. This lesson aligns with 13.2 in your textbooks. Two standards to cover in this lesson. The first one, understand radian measure of an angle as the length of the arc on the unit circle subtended by the angle. The second standard, explain how the unit circle in the coordinate plane enables the extension of the trig functions to all real numbers, interpreted as radian measures of angles traversed counterclockwise around the unit circle. Some key vocabulary for this lesson: radians, degrees, arc length, coterminal angle, reference angle, and the unit circle. These are all key terms, ideas you have to be familiar with by the end of this lesson. In the past, when referring to angles, we've usually talked about them in degree measurements. Now we're going to discuss radian measures. When we're talking about trig, pre-calc, calculus, radians are used most often. So now we're going to discuss that method. And we're briefly going to go through where the measurement for a radian comes from. If we have a unit circle means if we're going from the center and I construct a radius, that is a measurement of 1 unit. All right. Now if I construct an angle, when we're referring to this angle in radians, that is referring to the distance of the arc length formed by the two sides of this angle. Okay, so if we have a radius of 1, that's a unit circle. Open up this angle to the terminal side. This arc length, that distance, is the radian measure. Now we're going to discuss how to convert between these two types of measurements. If we're trying to convert from degrees to radians, we have to take our given value and multiply by pi divided by 180 degrees. If we're trying to convert from radians to degrees, we have to multiply by 180 degrees over pi. We multiply this value because this value is essentially 1. Pi radians is equal to 180 degrees. Now we'll go through a few examples. If we start with 60 degrees, we want to convert this to radians. We know this is in degrees because we have our degree symbol. So we need to multiply by pi over 180 degrees. Now we can simplify because 60 goes into 180. This would be 1, and this would be a 3, which would simplify down to pi over 3 radians. When we're in radians, we do not have to have a label. Sometimes you may see RAD as the label. If there's no label written in, it's understood to be a radian measure. Now we're going to discuss how to convert from 2 pi over 3 to degrees. So now we need to multiply by 180 degrees over pi. If we do that, some things are going to cancel out. The pi's cancel each other out. 180 divided by 3 is going to be 60. 60 times 2, we get 120 degrees. So that's how we convert from one unit measure to the other. Next, we're going to discuss the formula for the arc length if our measurement is in radians. We have S equals R times theta. This is the formula we use if theta is measured in radians, R is the radius, and S is the arc length. So suppose we have the circle. We're looking for this arc length created by this angle. We know the angle that is formed measured in radians, 2 pi over 3, and the radius of this circle is 6 units. Now we just have to fill in the information we know. S is going to be equal to our radius, which is 6, times 2 pi over 3. If we simplify, 6 divided by 3 is 2. 2 times 2 is 4 pi. So that means the distance of this arc length would be 4 pi units. So far we've discussed how to convert between radians and degrees. and how to find the arc length if we're in radian measure, now we need to discuss coterminal and reference angles. Coterminal angles are angles in standard position that have coinciding terminal sides. Reference angles are acute angles formed by the terminal side of an angle and the x-axis. When it discusses standard position, if we have a circle and we're going to construct an angle in here, by the center of our circle, if we think about the coordinate plane, we have the positive x-axis. We always start our angles on the positive x-axis. That's what standard position is. If we're having a positive angle, we're going to open up counterclockwise. If our angle is negative, we go clockwise. In this example, we want to find the coterminal and reference angles for this angle. We have this angle in standard position because the initial side is on the positive x-axis, and we have our terminal side. We open up counterclockwise so our angle is positive. Coterminal angles are going to have integer multiples of 360 degrees. For instance, if I started on this initial side, I made a complete circle, and then I continued around until I got to that terminal side, I'm going to have the same terminal ending point. Okay, so these would be coterminal angles. I have to take the 360 degrees for the complete cycle plus 135 degrees. So an angle of 495 degrees in standard position would be coterminal to this 135 degree angle. I could also go clockwise. If I start on the initial side, go around clockwise until I get to that same terminal side. Now I would have to subtract. If I took 135 degrees minus 360 degrees, I would get negative 225 degrees. Notice all I had to do to find a coterminal angle was take our standard angle we started with, add 360 degrees to get 495 degrees. I subtracted 360 degrees to get negative 225 degrees. To find a few more coterminal angles, I could add 360 degrees to 495 degrees. I could subtract 360 degrees from negative 225 degrees and continue that pattern on and on to find many different coterminal angles. Now we need to find the reference angle. So we have to look at the terminal side of our angle and the x-axis. So if I construct this line on the x-axis, our reference angle is going to be this angle that is created. It's always going to be less than 90 degrees and it's going to be positive. So we know if we're on the negative x-axis side, that's 180 degrees minus 135 degrees, our reference angle would be 45 degrees. To end this lesson, we are going to discuss the unit circle. We know this is a unit circle because it has a radius of 1. If I start at the center and go to the outside, it's a distance of 1. There's a lot of information on this circle, so let's discuss what each piece represents. First, we can see we have measurements for the degree. If I'm looking at the angle created by the standard position, so the positive x-axis, and I go here, that's an angle of 45 degrees. If I go from the standard position to here, that would be 60 degrees. So you can see that continuing all the way around this circle. Just inside that, we have our radian measures. So 30 degrees is the same as pi over 6 radians. 120 degrees would be the same as 2 pi over 3 radians. So these numbers along the inside are the equivalent radian measures for the outside degree measures. Now on the outside of the circle, you can see we have all of these ordered pairs that are created. So let's discuss where those come from. If we're looking at this 30-degree angle, I'm going to draw a line from this intersection on the circle perpendicular to the positive x-axis, so this is a right angle. And now I'm going to draw a line from the center along the bottom. So So notice we have a right triangle. The radical 3 over 2, that is referring to the distance from our center to this point of intersection. The 1/2 is the distance from the point of intersection on the circle straight down to the positive x-axis. Okay, so we have our x value and we have the y value for this triangle, this right triangle that is created. We could use that same concept for 60 degrees. If I go from this intersection on the outside and go straight down, we have our perpendicular. Now, if I construct the other part, the bottom portion of this right triangle, this distance along the bottom is going to be 1/2. Distance vertical for this right triangle is going to be radical 3 over 2. So these ordered pairs are created by the right triangle that can be created from the intersection on the outside of the unit circle. Now that we've gone through all that information of what all these values represent on the unit circle, the degrees, the radians, the ordered pairs, now we have to discuss how trigonometry is involved. Let's say I was looking for the cosine of this angle we're working with in this triangle. Our radian measure was pi over 3. So if I'm looking for the cosine of pi over 3, cosine refers to the x value. So all I need to do is find the x value of this triangle that was created, which we know is 1/2. If I'm looking for the sine of pi over 3, that is equal to the y value of this triangle that's created, which we know is radical 3 over 2. So cosine refers to the x value, sine refers to the y value. That is something you simply have to remember. Cosine refers to x, sine refers to y when we're dealing with these right triangles on the unit circle. We could also find the tangent of pi over 3, but we cannot directly see that on the unit circle itself. All right? Tangent is equal to sine divided by cosine. So if we know what the cosine of pi over 3 is, we know what the sine of pi over 3 is, we can use that information to find the tangent of pi over 3. So if the tangent of pi over 3 is equal to sine over cosine, that is the same as radical 3 over 2 divided by 1/2. Well, if I'm dividing by a fraction, I can take that and multiply it by the reciprocal. So essentially I have radical 3 over 2 times 2 over 1. Everything cancels out here. So we're just left with radical 3. So using some creativity, understanding the relationship between tangent, sine, and cosine, we know tangent is equal to sine over cosine. The tangent of pi over 3 is equal to radical 3. Now you're going to use the unit circle to find the value of each given trig ratio. So we're looking for the cosine of 5 pi over 6, the sine of 5 pi over 3, and the tangent of 5 pi over 4. If you feel comfortable trying this, I recommend pausing the video, going through, trying to find all these values, and then checking to see if your answers were correct. So first, we're looking for the cosine of 5 pi over 6. That's measured in radians. We need to find that radian measure. 5 pi over 6 is equal to 150 degrees. So if we're looking for cosine, cosine refers to the x value. The ordered pair, the x value is negative radical 3 over 2. The next one, we're looking for the sine of 5 pi over 3. So now we need to find where 5 pi over 3 is. It's in the fourth quadrant, equal to 300 degrees. If we're looking for sine, sine refers to the y value, which is going to be equal to negative radical 3 over 2. And the last one, we're looking for tangent of 5 pi over 4. Takes a little more work now because we can't directly see tangent in the ordered pairs. we have to remember that tangent is equal to sine divided by cosine. So if we find that radian measure 5 pi over 4, we have to take the y value divided by the x value, the sine divided by the cosine, negative radical 2 over 2 divided by negative radical 2 over 2. Anything divided by itself is 1. Thus, the tangent of 5 pi over 4 is equal to 1. In this lesson, we discussed many terms. We discussed how to convert from radians to degrees or from degrees to radians. We discussed the formula for arc length, S equals R times theta, when theta is measured in radians. We also discussed coterminal angles, which we can find by adding or subtracting multiples of 360 degrees to our given angle. We discussed reference angles, which refer to the positive angle created from the terminal side to the x-axis. And last, we discussed the unit circle, where we can now understand how those ordered pairs relate to sine, cosine, and tangent of those angles. Remember that cosine is referring to the x value, sine is referring to the y value, and the tangent, we have to take sine divided by cosine.